may review the stories. The top story is a Daryl special, and it's on the first photographs with the uh, from the web. And here comes Norman. The next story, the coronavirus story, the headline says, headed in a bad direction. The Omicron variant may bring the second largest US COVID wave. I feel like I'm personally surfing that wave along with my wife this week. The technology story I have is an example of something that I was afraid of, and that is BMW is now selling drivers access to the expensive seat heating system that you pay extra for the car. And now not only do you have to pay extra for it for the car, if you want warm seats, they want you to pay them $18 a month. So we know that they're after recurring revenue and envious of all these internet companies. Then, in terms of the environment, from Australia, their energy authority says rapid and irreversible, and they're talking about the energy crisis is accelerating their switch to renewables. And they're an example of what's happening around the world. In materials, the story is materials with nanoscale components will change what is possible. And I'll talk a little bit about this. And this is one of the frontiers where real change is going to end up happening. When you have new materials, you can make new things. And this is a whole different kind of generation of new materials. In space, the story is about dark matter, and the review suggests that it's time to ditch dark matter in favor of a new theory of gravity. And I've been reading about this for a while, and it may be that the reason why we haven't found dark matter is that it doesn't exist, which makes it hard to find. Then in biology, there is some fairly amazing information that they've gotten about the evolution of brains out of 500 million year old fossilized brains. And it really has provided a whole different kind of insight into evolution of brains. And again, it's based on fossils that are more than 500 million years old and still had good enough resolution to be able to provide insights into this soft tissue. In the human story is about friends. It turns out friends enjoy being reached out to more than we think. And I think for me, this story encourages me to think about who have I not reached out to in a long time. And then in medicine, the story is a major step forward for organ biofabrication, and it has to do with uh, insights that they have developed and techniques that they have developed that looks like they will lead to biofabrication of new heart tissue and eventually new hearts. So you can have your fresh 3D printed heart to drop in. So with that, let us go. Let me change my picture. The first story is about the web. And this week, then the web has released the first 5 uh, photographs, and these are high quality images from the web. And let me uh, show you something. I found something that is interesting. I don't know if you have seen these, Daryl, but these are comparisons of the Hubble, which you see here, and the Webb. So you can see that the Webb provides immensely more detail than the Hubble did. Here, let me show you the same view on a few other pictures. Here's the Carina Nebula. We've all seen this picture, but here is the difference between the Hubble and the Webb. Much better resolution. Then there is this galaxy cluster. We can see there are lots of stars there, but if you look at it, saying lots of stars is a big difference. And in the background, the little tiny red dots are galaxies 13 billion years old.
At one point, I heard there's only 18 stars in this photograph. The rest are galaxies.
Oh my goodness. Okay. Wow. That also says something. And then the picture that Daryl was showing us of Stephan's quintet, here was the picture with the Hubble. Excuse me, that's the Hubble and that's the Webb. And again, we can see a lot more detail, and that shouldn't surprise anybody because seeing more detail was, what the Webb was about. The other thing that the Webb was about is that because it is in space and has different instruments, it can see into the red and infrared a lot better. And that means it can see through clouds that of stars that visually limited what you could do with the Hubble. And here they're able to see the stars behind it from their infrared light. Now, also one other thing that I didn't realize with the Hubble, the deep field pictures, which were the best of the Hubble pictures, took an exposure time of 2 weeks.
Wow.
And these photographs from the Webb were just a matter of less than a day, I think just hours.
12 hours, most of them.
Okay. And so imagine how much more you can see if it takes you 12 hours instead of 2 weeks to take the photograph.
Yep.
And so that is also going to be a great deal. Now, one of the things also that they checked about, we don't have photographs of this, but one of the things they did is they looked at an exoplanet WASP B giant hot gas planet that's orbiting a star about 1,000 light years from Earth. And what's interesting there is they shot it while the planet was transiting in front of the nearby star, and the Webb is got good enough optics that during the transit, they are able to see the effect of the starlight being filtered through the planet's atmosphere, and are able to say with a fairly good basis that there's water there. And so that kind of measurement is really interesting. And they believe with that same technique, they're going to be able to see in atmospheres of exoplanets the fingerprints of oxygen, nitrogen, ammonia, and carbon. In other words, evidence of life on that planet. And so, again, it's going to be a uh, powerful new instrument. And the first week is impressive. And they say this was hard to do. It's difficult to express just how hard it was. There were so many thousands of ways in which it could have gone wrong, but it didn't go wrong. It all came together, and now we're starting to see the fruits of it.
Yeah, I think it's amazing. What they showed us in the first week is visual items, things we can see with visual light.
Uh-huh.
And what Webb has more on it than Hubble are instruments that don't show visible light, but infrared, near infrared, a lot of different instruments that to us, we're going to see little charts and things like that. But those charts are doing what you just said, showing oxygen, water vapors on planets, or around different stars. And it's just amazing that I can't wait for more pictures and charts.
Yes. And, if you look at it, the first 100 days of the use of this Webb, the astronomers have been planning out for 20 years what to do during this period. And so I suspect that there are lots of good stuff that we're going to be seeing, each week for the next months.
Right. One thing you might notice on the Webb photographs versus Hubble is on stars, there are these diffraction spikes. You might see them as spikes on the star. And a lot of astrophotographers are complaining about those because they're complaining they get in the way. Like you can see the stars behind me in this
Yes.
photo. They don't have those big spikes.
Right.
So that's the only thing I've heard about Webb that can be called a complaint. But it's just inherent in the structure of the telescope with those with the camera being on one end and the structure holding the instruments out here. You're going to get those spikes.
And so they're complaining that the stars are too twinkly, huh?
Yeah.
Okay.
I know I'm just kind of preaching to the choir, but we always have to keep in mind that this is a snapshot of the universe at this particular second somebody told me one time that this probably never did exist and it never will exist exactly like this. And we got to remember that a lot of the stuff that we see, they don't exist anymore.
Of course.
They're gone.
That's correct.
And
Right.
and that's why we'll never have aliens come and visit us, because it's just too far away.
Well, I've heard the web called a time machine.
Absolutely. That's a good description.
Yeah.
Okay, so now let us go on, headed in a bad direction with COVID. And as I say, this story for me is after my wife and I, having avoided COVID for 2 years, both of us and another friend from the neighborhood came down with it last week. Carol is still feeling pretty crummy. I'm at least able to function relatively okay. But anyway, it's this BA5 subvariant, and they're saying this may bring on the second largest ever COVID wave in the US. And the problem with the BA5 variant is that it evades the immune system and can cause reinfection even after vaccination and previous illness. And it's now the majority variant in the US, and it has done that within really just a matter of weeks. And it comes at a time where the US is experiencing serious COVID fatigue and relaxing restrictions in public life, and are trying to return to normal. And, you know, it says COVID-19 is clearly not over, and we're seeing dramatic increases in cases and hospitalizations in the US. And when it happens in the US, then it happens in Mexico a few weeks later. In the US, there are more than 100,000 new cases of confirmed COVID every day. So hospitalizations are increasing. And in news for us, the older you are, the more likely you are to be hospitalized. So the thing about the BA4 and 5 is that they are evolving to evade protection from infection, from vaccination, or from previous illness, and it seems to be more transmissible, and they can again break through existing immunity the easiest. One of the things that is good news, though, is that prior immunity still seems to hold up well against severe outcomes like hospitalizations and deaths. So like us, you may be more likely to get it, but if you get it, you're not and have been vaccinated, you're not likely to end up being hospitalized. And it's still the case that keeping up with your immunizations is the right thing to do. And we can't let our guard down now, I believe. And as my own life has shown, they say the virus has surprised us too many times already. So be careful out there.
There is good news. The Novak vaccine, which is not an mRNA,
Yes.
is apparently effective against the Omicron variants.
Ah, good. And that one is a protein-based one, so easier to distribute and store and handle, which is a big deal.
So where do you get it?
America,
Oh,
I don't know whether it was approved today or not. But the approval seems surely to come right
Right.
away.
right. And wherever it is, I had thought the approval was imminent anyway, and you're saying that too. Okay.
well, I won't be in the US until the beginning of September.
Well, you'll be able to go down to your pharmacy and get it.
Yeah, I guess. But I don't want to get sick before that time.
No, don't get sick before then. Now, I don't know. I am sorry. When I was about 6 years old, I had a bunch of allergy tests where they would come and give me, 20 injections in each arm. And, now I'm just fantasizing about getting COVID injections, 20 in each arm to make sure I'm covered. It's not going to be that bad, is it?
I hope not.
We can't
Yeah,
even feel injections anymore. The needles are so sharp. It's
Uh-huh.
not like in our youth.
Well, as a 6-year-old, I felt the injections. Maybe it was just old needles, but it took me another 30 years before I could tolerate having shots.
Well, you just don't look when they do it. And
Oh, that's right. That's right. That's the first thing I learned is to look away.
yeah.
Okay.
all right.
Now, if there's nothing else, then let's go to the technology story. The subheading on this was Welcome to Microtransaction Hell. And again, it amazes me. BMW wants you to spend another $18 a month to keep your heated seat subscription. Now, you had to pay extra for the heated seats to begin with. And to actually use the feature that you paid for, they want you to pay them $18 a month. Now, they haven't rolled this out worldwide. They're just starting in South Korea. I guess it gets cold there in the winter and you really need your heated seats. And BMW is also putting some other basic features behind paywalls, like another luxury accessory that you pay for is a heating steering wheel. You can turn that on for only $12 a month. And if you want to keep the recording from your BMW cameras, that's only $235. I don't know if that's a one-time cost or a perpetual license or what. And it turns out this is not the first time that BMW tried to do this. They previously had tried to charge its customers $80 a year to enable the Apple CarPlay and Android Auto connection, which is a feature that's considered standard in most other cars, especially in this price range. This failed though, because they got so much bad press and negative customer reaction that they retracted this. I suspect the same thing may happen to the $18 a month to turn on the heater, but the effort shows still what the next generation of auto manufacturers are going to be trying to do is I think they are entranced by the recurring incomes that are available in these internet applications, and they're trying to figure out how to get them a piece of it. So what do you guys think?
Well, I would never buy a car where I'd have to, pay for some of the features that are in it. Just to use the features. That makes no sense to me.
Right. To me, neither. And especially if it's not an inexpensive car, if it's a luxury car to begin with, you
Yeah.
expect to, have
Right.
luxury features.
Yeah.
So what's next? What's next? You buy the car and now you need to spend 150 a month to start it.
That's right. Or maybe we'll let them start it. We just have to pay $150 a month to turn right.
Yeah.
I have one of those luxury cars, and it's a computer on wheels,
Yes.
and everything is automated. If I want to open my glove compartment, I have to use my iPhone and press a button for it to open. Now there is ways to do it without, but the other way you do it is inside the car on the computer that's in the car. And it doesn't surprise me that we're going that way. For example, I had a little service issue that needed to be taken care of, and I didn't call them. I got on my iPhone, went to the service part of my app, told them what my problem was, and they fixed it remotely. And and when you have a car that doesn't need to be serviced for 50,000 miles, and you don't need to go to the service place to get anything done except physical things. That's the future, I think, of automotive industry.
Right. And it's another place where there are a number of good paying jobs as auto mechanics that are just going to disappear.
Can't be stopped.
And in every industry that this type of stuff's happening, the hackers get involved. It's like you pay me $100, I'll hack your car so you don't have to pay the 12 a month.
Okay.
Right.
Or you pay me $100 and I'll unhack your car so you can get in it and open the door.
Yeah.
I think I'll practice walking.
Well, it's a different world that we're moving into. Okay, the environmental story is from Australia, and their National Energy Institute is saying that the energy crisis is accelerating the switch to renewables and that it's rapid and irreversible. And the switch to renewable based grids is complex, but it's happening there really fast. By the time this decade is over, let me find the numbers. I think they will be at right now they're 30% renewable, and by the end of this decade, they plan on being 83% renewable then 96% by 2040, and 98% by 2050. This requires tens of billions of dollars in investment. And, the plans they have will depend also on batteries to be able to pick up power and provide power when uh, the renewables are not able to. They will still have gas. The gas will be these peaker plants that provide power when it's short everywhere else. The amount of gas they're going to need to power these peakers is going to be less than the gas that they use now. And it's likely that a good portion of that gas will be biogas or hydrogen. What Australia is also very busy working on is they are trying to be a major source of hydrogen, and there are big companies that are spending tons of money on this, and the impact of this hydrogen is not even figured into the equation. So they're saying, really, if you look at Australia, besides the revolution that we're going through currently in terms of the switch to renewables, there's going to be a second revolution that is coming, which is the starting to increase the use of hydrogen massively. So Australia, in this way, looks like they are one of the leading major economies in the world in terms of this switch to renewables. And again, the fact that they say irreversible is an evidence of the changes that are happening. I think we're a little behind Australia and Mexico.
With AMLO's attitude towards renewables, of course we are behind.
That's right. Well, I think AMLO needs to not be renewed. When is the election? Another 3 years?
And of course, he's not eligible to be reelected.
Right, I know. But
a president can only serve one term. But I was amazed that only 10% of other Mexicans, voted in his recall, and 90% of them didn't want to recall him. They were happy with what he's done, which is amazing because he's done such a terrible job.
But his predecessor was worse.
In our humble opinions.
I don't
Yeah,
know
well,
if we have
exactly.
any humble opinions here.
Well, if there's a silver lining to the war in the Ukraine, it could be that we've sped along the path to change our climate to the
Yes.
better.
Yes, yes. And certainly one of the things that you hear now that you didn't hear a year ago was the risk that is involved in this fossil fuel use. The risk of, the euphemistic term is supply disruption. And the thing about renewables is that they are not subject to that risk, except when the wind stops blowing and the sun stops shining.
Yeah, well, then we might as well just wave goodbye.
Okay. So the next story is about materials with nanoscale components. And uh, these guys are saying this is going to change what is possible. And the guy who wrote it has spent 24 years working as a materials scientist. And he says he has been inspired all this time by hierarchical patterns that you find in nature that repeat all the way down to the molecular level. And such patterns show remarkable properties, like, for example, our bones. They strengthen our bones without making them heavier. They also do things like give butterfly wings their color and make silk that makes spider webs. And so, what if we could uh, design and engineer such properties directly into manufactured materials? And this could then remove need for complicated manufacturing processes. And we may be able to program some degree of intelligence into the materials themselves, which again makes new things possible. One idea that I heard about some time ago with that is to make building materials that, in the event of an earthquake, stiffen to protect the building, or relax to make the building be able to move and bend and not break. And with the advances in 3D printing and other forms of additive manufacturing, they make it now possible to organize and create these small structures down to the nano size, and to be able to make these kind of uh, new materials that have new possibilities. And this is going to end up changing what we are able to make and conceive of and do. This is one that is still early in the process, and we don't have concrete results to show yet, but uh, they will be coming, and this will be one of the dimensions of kind of deep change in the way we make things.
Well, if they would do it to clothing, for instance, we better get used to to whatever clothes we have, because they keep renewing, right?
That's
So
right.
you just never wear them out.
Material with AI involved?
Uh, so far, I haven't heard about AI used here. It wouldn't surprise me that it's there as an analytical tool.
That would be the next step.
Well, okay, I don't know if I want my blocks to be smarter than I am.
Your coffee cup could say, stay the same temperature.
Uh-huh. But hey, if we could do it that way, maybe I could make a coffee cup that if I knocked it over, instead of spilling, it would just make itself be vertical.
Ideas, you better patent that.
Okay. Okay. Well, I'm afraid that is like conceptual art. I know these conceptual artists, and it's actually kind of neat for them because they can be an artist without ever making anything. I just had the idea.
No,
So,
but still, if you would have insulation, for instance, that would react to temperature changes,
right.
that would be an interesting thing. Yeah, that I can see how that could be done.
Yes.
Yeah.
Now, again, one of the things that they are talking about is making material that will deform itself under some circumstances, like, for example, uh, being able to, under the right condition, release some objects by releasing the grip of the structure on the object, or to uh, break apart under the right circumstances, or things like this.
Yeah, well, I was just thinking of fiberglass, it could swell up, for instance, when it's exposed to external heat,
Uh-huh.
and shrink down again if it's the heat goes away. Yeah, I'm just thinking like Europe is sweltering on an enormous heat dome, and lots of
Uh-huh.
people, hundreds of people are actually dying, because of heat, because they're not used to it.
Yes. Now here, maybe you could make contact lenses that would deform themselves as the heat change, so they'd always stay in perfect focus. Anyway, now the physics story for this week, I had talked about this a little bit before, but now this is the best article that I've read, and it's about dark matter. And, if you look at the universe, we can model the motion of the planets in the solar system very accurately using Newton's laws of physics. But in the early 1970s, scientists started to notice that this did not work out for disk galaxies. Stars at the outer edges of the galaxy were moving much faster than Newton's theory predicted. So, trying to figure out what's going on, they came up with this idea of an invisible substance called dark matter, which they thought could be providing the extra gravitational pull, causing these effects that we have seen. But about 30 years ago, there was an alternate theory of gravity proposed by an Israeli physicist, Mordecai Milgrom, and it's called MOND, MOND. And this theory did not require any invisible matter. And his main idea is that when gravity becomes very weak, as occurs on the edge of galaxies, it starts behaving differently than Newtonian physics. And using these ideas, then it's possible to explain why stars and planets and gas on the outskirts of galaxies rotate faster than expected based on just their visible mass. And one of the things about MOND is it does not merely explain what you see, it can be used to predict what you see. So the scientists think that this is very strong evidence for it, and that it makes MOND superior to the standard cosmological model. One example of that is that uh, if we know the distribution of visible mass in a galaxy, but do not know its rotational speed, in the standard cosmological answer, you can kind of estimate the rotation speed, but it's really plus or minus a brick. Its rotational speed might come out between 100 kilometers a second to 300 kilometers a second. So a fairly wide range. Mond makes a more definitive prediction that the rotation speed must be between 180 and 190 kilometers per second. So if you found a galaxy that was rotating at 188, both could be correct. Both theories could explain it, but Lamond is much better for predicting accurately what you're going to find. There also are other cases for the standard cosmological model just doesn't work. For example, there are things called galaxy bars, which are rod-shaped bright regions made of stars in spiral galaxies that are often in the central region of these spiral galaxies. These bars rotate over time, and if the galaxies were embedded in massive halos of dark matter whose gravity affected their rotation, these bars would slow down. However, the bars that they've observed do not slow down. They continue to be fast. This can be explained with Mond and can't be explained with the standard cosmological model. And so it turns out there are many of these failures in the standard cosmological model that have trouble under the standard model, but there are reasonable explanations under Mond. So this huge lead of Mond over the standard cosmological model leads them to conclude that Mond is a better explanation for what's going on in our universe than is dark matter. So maybe the dark matter that we are concerned about doesn't exist, and that's why we've had trouble finding it.
Something I just don't understand is Mond came out in 1982, 40 years ago.
Yes.
Why did we go with dark matter instead of Mond?
I think it's, I wonder if it is kind of scientist groupthink.
It's kind of strange. I remember in college where these free parameters, that's what you had to have the formula equal 0. So you had to plug something in to make that happen.
Right.
And that in this case was dark matter. And they couldn't explain it, but to make the formula work, you got to plug something in.
Right.
But it was a big plug.
Right. Yeah, I remember when I was in a semiconductor company dealing with accounting issues, I discovered an accounting device called WIDIB, which is what it takes to balance. So you just put a WIDIB there and it all works out. They did the same thing with dark matter, I think.
Yeah, probably so. I was not in accounting, but I was in budgeting. And what we had, we found a computer a mini computer that would prorate your number to anything he wanted. So you had a list of a dozen, maybe 100 things, but it came up with the wrong answer. So you plug in the right answer and you prorate it back to so everything was right.
Yes. Yes.
So much for science.
Well, this is accounting. This is
All right.
this is the guys doing the books, cooking the books
Yeah.
to
Well,
make everything balance.
Because called cooking the books, right?
Yes, yes,
well, I think you're right. They put in dark matter because they had to make everything balance. It
Right.
wouldn't balance. But
yes.
but still, Mond was 40 years ago. Why
Why
is
did
it?
it take them so long?
Yeah. And I wonder if the scientists of today are willing to drop dark matter that quickly. The paradigm shift probably won't work, or it's going to be hard.
Now, there's also another thing in physics that I wonder about. It's Einstein's cosmological constant, which to me sounds like one of those WIDM things, and it's some number they can't explain that is baked into a lot of Einstein's work. And how did he get it? Well, that's what it takes to balance the books. We'll find out later.
I wanted to add that there's nothing wrong with that. I mean, that's how you have to work when you're on the frontier of knowledge. You
Right.
have to plug that in. So there's nothing wrong with it, but
Right.
still,
It's true.
we've been living with dark matter for a long time. I imagine we have graduate students and PhDs that they got their degree based on that, and now 40 years later, we're maybe going to something else. It's going to be hard to do.
Now, that's interesting. If dark matter is established not to exist, will all the PhDs that are based on it be rescinded?
Yeah, to take them away.
I sort
Okay.
of doubt.
That's the trouble with some of this science stuff is, like you were saying, science for a long time is just our best guess. We call it our best understanding, but until we're certain, we're just guessing.
Yeah.
And as we get better, we make better guesses. I remember learning about Newtonian approximations when I was in math, and these were about how to guess and continue to refine your guess so the guess is better. Okay, now let us move to biology. And what I want to talk about is an 500 million year old arthropod. Arthropods are those critters with an external skeleton that are joined together, and they are the most common life form on the planet. I've heard there are more of them than mammals or any of those other critters. And here, these were in the Cambrian era. That's about 500 million years ago. And they were one of the dominant life forms at that time. There were versions of it that were the biggest creatures on the planet at that time. They were a meter long. These were about 20 centimeters long. And anyway, what they found was there were a bunch of fossils that they found. And in 84 of these fossils, the remnants of the brain and nervous system are still preserved 506 million years later, which is a long time for soft tissue to be preserved. And they can even make out fine details, such as the visual processing centers that serve the three eyes and traces of nerves entering the appendages. And the details are so clear, they say, it's like we're looking at an animal that died yesterday. And part of what they're able to see is in the brain structure. They see in these early arthropods, the brain structure had two different parts. This was an early evolution. The modern arthropods have three sections. So it's like you're looking uh, at a Rosetta Stone of evolution. And it gives them now different ideas about the development of brains and living bodies. And it's amazing that they're able to get this kind of good resolution from fossils over 500 million years old. I think this was an unexpected discovery and is one of the things that will cause a rethink in the idea of the evolution of insects and spiders and brains.
So where do they find these
They
ants?
found them in some rocks. They found them in a kind of rock formation.
I mean, they should have not been exposed to water during all that time. They would,
Yeah, I don't know. But suddenly they're preserved like that, they probably were dried out.
amazing.
Okay, so now to the human story, and it turns out friends enjoy being reached out to more than we think. And it turns out that people consistently underestimate how much others might appreciate an unexpected phone call or text message or email just to say hello. And it turns out the more surprising is the connection, then the greater is the appreciation. And people are fundamentally social beings and enjoy connecting with others. And this research suggests that people significantly underestimate how much others will appreciate being reached out to. And they found that people receiving the communication place greater focus on it than the people who initiated the communication. And this heightened focus is associated with higher appreciation. And again, they found that people underestimated others' appreciation to a greater extent when the communication was more surprising as opposed to stuff that was just in the regular communication pattern. So one of the reasons why this is important for people like us is it turns out initiating social contact after a prolonged period of disconnect can feel like a problem in many people's mind because people worry about how the gesture, this communication from a voice from the past might be received. And these findings suggest that this hesitation may be unnecessary, as the others are likely to really appreciate being reached out to more than people think. So here I ask each of you, uh, is there anybody from your past that you haven't talked to in a while that is worth reaching out to? I think I have a guy I want to reach out to.
Yeah, I know someone that I've been thinking about, but so far I haven't taken any steps. But I think I have a phone number or some kind of way to connect him. The first guy that I met when I came into
Well, this story says, don't wait. They will appreciate it when you do it, and they'll appreciate the contact more than you imagine. So why
Yeah.
wait?
well, good question.
And again, for me, this story with our age group, these kind of social content tax are one of the things that very much improves the quality of our life. And I think that makes it worth doing.
Well, the Unitarians are talking about this very thing every week, basically.
Uh-huh.
But the outreach among members that are exposed to this message is
Uh-huh.
still not there.
Yes. Yes. I think that's one of the important things that happens with the Unitarians.
Yeah.
Is this connecting with each other,
Yeah.
even if it's just saying hello before the service starts on Zoom.
Yeah.
Okay. And the last story, the medical story, is about a major step forward in organ biofabrication. Heart disease, one of the reasons that the heart disease is so deadly is the heart, unlike other organs, cannot repair itself after injury. And because of this, this whole area of tissue engineering, ultimately including the fabrication of an entire human heart for transplant, is so important in the future of cardiac medicine. And to be able to build a heart from the ground up, uh, researchers have needed to figure out how to replicate some of the unique structures that make up the heart. And this includes the uh, muscle structure of the heart, includes helical geometries, and these helical geometries cause a twisting motion as the heart beats. And it's long been theorized that this twisting motion is critical for pumping blood at high volume. It's been difficult to prove this, though, but now bioengineers at Harvard have developed a biohybrid model for human ventricles that have helically aligned beating cardiac cells, and have shown that this muscle alignment does in fact dramatically increase how much blood flow that muscle can pump with each transaction. This advancement was made possible using a new method of additive textile manufacturing, a version of 3D printing. And this is a major step forward in organ biofabrication and brings us closer to the ultimate goal of building a human heart for transplant. Now, in the background, there's something that is in pretty old memory in or mystery. In 1669, that sounds like a while back, an English physician who had counted John Locke among his colleagues and King Charles II among his friends, he first noticed this spiral-like arrangement of the heart muscles, but the it turns out this has been increasingly hard to study, or frustratingly hard to study, because we didn't have a way to be able to model it or try different variations until this new printing technique came about. But with this printing technique, they were able to test out the hypothesis that the helical muscles increase the blood flow. They're able to do different forms of alignment of these tissues, and found out that the helical arrangement is the stuff that provided the best flow. And the human heart has multiple layers of these helically assigned muscles with different angles of alignment. And with this new printing technique, they can replicate these complex structures in a precise way. And they believe that through this work, they're going to end up being able to bioprint you a new heart.
Hmm.
So I don't know where we sign up to get on the list, but it's coming.
Well, just a new heart alone is going to be a challenge. I mean, suppose that they succeed in this, then the rest of your body too has been aging, and
Well, this will be an alternative. One of the other things I'm reading about still is heart transplants from pigs.
yeah,
And, that's still something where they're making genuine headway with.
I'm sorry that Susan is not on this time, because she, I think, would have a thing or two to say about this. Yeah. Anyway,
Well, anyway, I thank you all for your attention and your comments this week. And it's good to see you, and we'll see you next time.
I'm glad to see you. We're looking as well as you do. You're considering that you. And so, how is your wife doing with COVID?
Okay.
Anyway,
Thank you, Richard.
thank
Okay.
you. Thank
Good
you.
to see you. Good to see you. Glad to be feeling well enough to do this.
Good. We're glad that you are doing this.
Okay. Adios.
Okay. Adios.